Do we have everyone here? Are there any more students to join? Shall we start?
Okay, sir.
1 minute. Yeah. So just let me share it. Right. So we had done the questions till 6.3, question number 17, right? Isn't it?
Yes, sir.
You were doing this now?
Yes,
Application of
sir.
derivative
Sir, we are doing
and
application. Yes, sir, application derivatives, sir.
yeah, application of derivatives and maximum minimum you were doing now.
Yes, sir.
Sir.
And I guess in that you had done till question number 17. Am I wrong?
No, sir.
117, sir.
Okay, so till 17 you have done, you have to start from 18, right?
Yes, sir.
Sir.
Okay, so you can start doing these questions. Okay, I'm here and we'll discuss at the end. First, I would like you to answer these things because I think you have studied. Do you have any doubt in the concepts?
No, sir.
Right. Okay. So you can start with it. Start with the first question. Hmm. Taking too much time. Shall I do it? Tell me. Oh, we have lots of students from the previous class also, na? Shall I do it?
Yes, sir.
But I want you to solve. You should do anything that you can. Should go anyway. Okay. Doesn't matter if you're going in the correct path and you're going to get the answer or not. But the thing is that you should work upon it. Only then you'll be able to think about any question. So can anybody tell me what he thought? Please talk with me. Yeah, go on.
Repeat, sir.
Can anybody tell me what you thought about the solving process? Okay, no problem. See, we have been given with a rectangular sheet of 45 centimeter by 24 centimeter, that is length by breadth. Okay, it is in this order only, length by breadth. It is to be made into a box without top by cutting off square from each corner and folding up the flaps. What should be the side of the square to be cut off so that the volume of the box is maximum? Now see here, let us say that the square to be cut out is x centimeter. If you are cutting out the squares of x centimeter, right? If we are cutting out x centimeter, okay. How can we say? Now see here, the length will be what? Length will be 45 minus twice of x, and breadth will be 24 minus twice of x. Agree, everyone?
Yes, sir.
Okay. And that is to be multiplied. One more thing. The volume, for volume, the height will be what? If you have taken a square box that is to made into a cube, so height will also be x only.
Yes, sir.
Right?
Yes, sir.
So what will the volume? Volume will be length into breadth into height. So 45 minus twice of x times 24 minus twice of x times x. Do you agree with this? Yes or no? Everyone tell me.
Yes, sir.
Yes, sir.
Okay. Divya, Shirni, Neha. There are more of them.
Sir.
Netra, Sai, Adokshajan, sorry. Ananya, Vaishnavi, Prakash, all of you. I want the answers from all of you. Okay. So this will be the volume. Now, if you multiply this, what will you get? Multiply this to get the equation. Do it yourself. Multiply this. You should be in a habit of solving long numericals. Multiply this to get the solution.
Yes, sir.
Tell me the equation that you get after multiplying this.
Doing
1 minute, sir.
Yeah.
Sir,
Yeah.
1080 minus 138x plus 4x square into x.
1080 minus. Pardon? Minus
138x
138x. Then
plus 4x square into x.
that's good. That's correct. Okay, so you get this. So if you multiply the x value, you're getting 4x cube minus 138x square and plus 1080x. Isn't it? This is what you would be getting. Now, in order to gain the maximum value of the volume, what do we do? And with respect to what? We need to maximize this volume, and with respect to the x, the cut length that we have to make. And how do we get the maxima? We get the maxima by putting this to 0 and get that value of x. Isn't it? This is what we do now. Agree or not? This is what we do. We differentiate of what we want to get the maximum or minimum value with respect to what that is variable. So our x length is variable and we equate it with the 0 and we get that value of a variable, and then we put to get the maximum or minimum value of the volume or whatever quantity we need to get. Yes or no? Please say.
yes, sir.
Right? Agree? So what you do, can you differentiate it?
Yes, sir.
Can you differentiate this equation and tell me the value of differential? Try to differentiate it.
Sir,
Hmm.
is it 12x square minus 276x plus 1080, sir?
12x square minus 276x plus
1080, sir.
1080. That's correct. That is correct. Yes. Okay. Now what you have to do, you have to equate this to be 0 in order to get that x value. Agree? So the easiest way from here you can proceed is like take the common part out. So I think that 12 will be common here. If I'm not wrong, try to check that. Take 12 out, factorize it. There are different methods of factorization. Factorize it. If you don't get factorization, you can directly apply that that rule, that quadratic rule. Okay, there are two solutions. X is equals to minus b plus minus root under b square minus 4ac upon 2a. You know that, everyone? Okay, so try to factorize it first because that is quite lengthy. Try to factorize it. It will get factorized, and then you go towards that quadratic formula if it doesn't get factorized. Try to solve this. This is what I got. Check if you agree with this or not.
Yes, sir.
You all agree with it,
Yes, sir.
right? Now see here. So it is x is equals to 5 or x is equals to 18, right? Now, can you
Sir.
tell me if I have a length of 45 centimeter and a breadth of 24 centimeter, so can I cut a piece of length of 18 centimeter? Yeah. From each corner, can I cut 18 centimeter?
No, sir.
See, this is what it will be happening, because in the breadth side it will be overlapping, isn't it? Agree, everyone?
Yes, sir.
Right? So what will be my answer? My answer will be 5 centimeters, because this is not feasible. This is also possible, but not feasible. Agree? So you have to check like this. You'll be getting two answers. You have to check accordingly. So this is the answer. X is equals to 5. Now, what? Tell me the volume. Volume at 5 centimeters. What is the volume that I'll be getting at 5 centimeters? At x is equals to 5 centimeter, what will my volume be? Oh, one more thing. Before that, you check for whether this is really a maxima or not. We can get minima also at this point. Differential is 0. At that particular point, we get maximum or minima. How we confirm that, whether that is maxima or minima? How we confirm that?
Double differentiation.
Very good sign. Double differentiation. You go for double differentiation. Now dv dash upon dx. What will that be giving you? My v was, this was my single differentiation. So if I doubly differentiate it, what will I be getting? I'll be getting 24x, then minus 276. Minus 276. And now put the value of 5 here. V double dash of 5 will be giving me what? 24 into 5 minus 276. So that will be 120 minus 276. That will be giving you minus 156. And that is less than 0. That means this point is giving me the maxima. V at 5 is maxima. Everyone agree with this solution? Yes or no? Tell
Yes,
me.
sir. Yes, sir.
Yes, sir.
Good. So write it down and we will move on to the next question. Solving questions in maths and physics is at most important. You cannot get any concept. Even if you get the formulas, if you know the formulas, you know how to do something. You need to solve questions because there are tricks and some what shall I say that? Some turnings are there in every question. For example, here we got 5 and 18 as our answers, but the thing was that 18 was not feasible. So if you solve questions, you'll get that. Written, shall we move on to the next question? Sai, Divya, Hariharan, everyone.
Okay,
Shall we
sir.
move on to the next question?
Okay, sir.
Okay. So this is our next question. Show that all of the rectangles inscribed in a given fixed circle, the square has the maximum area. So if we have a rectangle, let me draw it. Do we have 3D shapes here? Let me see. 3D models. Stop 3D models. Okay, let us do like this. If we have a circle like this, okay, we have a circle like this, right? Now, inside the circle, we need to get something, okay, anything like we can inscribe it. Anything we can inscribe it in it. Okay. Right. So we have to inscribe anything that is, it can be a rectangle, it can be a circle. We don't know about the length, we don't know about the breadth. What you need to do, we can take it to be random. So you need to find that, like, to get this particular figure that is inscribed in a circle, to have the maximum area, that should be a square. Are you getting my point? You have to inscribe anything inside the circle. It can be a rectangle also, it can be something like this also, it can be having this shape also. But whatever shape you provide inside it, that should have the maximum area that can be inserted in it. Can you guess this? I'll be giving you some kind of hint. So what you do, you take the length. Let's say that this is the diameter, this is B, this is L, and this is A. Radius is A. So can we say that L square plus B square is equals to 2A ka whole square? Agree or not?
Yes,
Yes
sir.
or no? So B will be what? Under root of 4A square minus L square. Area will be what? L into B. So L into under root of 4A square minus L square. Now you see here in this particular equation of area, I want the area to be maximum. So in this particular equation of area, what is my variable? What is changing? What can I change? Tell me. What can I change in this particular equation of area here? So that I can differentiate with that particular variable and I equate it with 0 to get the maximum or minimum value and further checkings. Tell me. What is variable here? Is A variable small a? Is small a variable? Is this a variable?
No, sir.
No, because we have been given that the circle is fixed. Fixed circle, that means radius fixed. So what is the variable? The L is the variable, because we can change the length. We can give a figure like this. So there the L will be different. Now this will be the L. We can give a figure like this, more comprehensive. So L will be this. So what is changing here is my L. I can change my L to get the desired result. Agree or not?
Yes, sir.
Right? So I can differentiate area with respect to length, and that I put it to be 0, I get the value, and I put it in the double differentiation to get the solution, whether it is maxima or minima. So if you differentiate it, how will you differentiate it? See here. So it will be d upon dl of L times root under 4a square minus L square, right? So this is the multiplication rule we have to apply here. So I'll be writing this as L d under root of 4a square minus L square upon dl plus under root of 4a square minus L square into upon dl. Yeah, agree?
Yes.
Right? So this differentiation, for here I'll have to apply the chain rule. See how am I doing it? So d of under root of 4a square minus L square. So in the denominator also I'll have to write the same thing, 4a square minus L square into d of oh sorry. It should be written like this now. If I write it like this, see d of 4a square minus L square to the power 1 by 2 divided by d of 4a square minus L square into d of 4a square minus L square upon dl. So it will be what? 1 by 2 root under 4a square minus L square. Agree? Into 4a square is constant, so you'll get minus 2l minus dl square by dl, because this part was constant, so that will become 0. Do you get this or not? This differentiation?
Yes, sir.
Everyone, tell me. If you don't get it, I'll expand it more. Divya, did you get it? Hariharan, Srini, Neha.
I got it, sir.
Okay, Srini.
Got it, sir.
Yes, sir.
Neha got it. Divya, Sai.
I
Yes,
got
sir.
it.
Good, good. So I can cancel this too. So this will save my time. So what the equation will be now? It will be the second part is direct dl by dl. So that is the 4a square minus l square minus of l square upon 2l square was there minus 2l square. So 2 got cancelled with the denominator. Okay, 4a square minus l square. So I can write this as, if you take the LCM, you'll get 4a square minus l square upon under root of 4a square minus l square. So you'll get 4a square minus 2l square upon root over 4a square minus l square. Okay, if you put this to be 0, you'll get 4a square minus 2l square is equals to 0. 4a square is equals to 2l square minus 2l square, right? Sorry, plus 2l square. And you can find it out. L from here, L will be root 2 times a, isn't it? Isn't it? Got it?
Yes, sir.
Yes, sir.
Now, see it. To check whether this is maxima or minima, we need to differentiate it again. I need the double differentiation of d2a by dt square, sorry, dl square. So I'll have to differentiate this again, d by dl of 4a square minus 2l square upon root under 4a square minus l square. So now this becomes u by v. You know how to solve du by dv? So it will be, if you get something like of u upon v, so the formula goes like v du upon dx minus u dv upon dx upon v square. You know this,
Yes, sir.
Yes, sir.
right? So what I'll do take the denominator first, 4a square minus l square under root into differentiation of the numerator, 4a square minus 2l square upon dl, then minus, I'll write it 4a square minus 2l square, and then the denominator 4a square minus l square. It is quite lengthy, but we can do it by dl upon under root of 4a square minus l square ka whole square, right? Can anybody solve this and tell me? Or you leave? I'm doing. You leave this. So from there, what we get? We get root under 4a square minus l square, and from this differentiation we get it minus 4l minus of 4a square minus l square, sorry, 2l square. We get it from here 1 by 2 root under 4a square minus l square, and now we get here 4a square minus l square because the root gets cancelled. So ultimately, when you solve this, you'll be getting minus 12a square l. If you solve this, you have to multiply it from here, and then you get that as denominator, plus minus 12a l square, and then plus 2l cube, if I'm not wrong, whole divided by, okay, I'm writing the next page. So you'll get minus 12 a square l plus 2l cube upon 4a square minus l square to the power 3 by 2. And now if you put that l is equals to, put l is equals to root 2 times a, put it and tell me what value you are getting. Tell me what value you are getting. Put this, instead of l, you put there root 2 times a. Tell me what value you are getting. This is quite lengthy, but you don't have to get afraid of it. You have to solve these questions in order to gain that confidence that you can do anything. Isn't it? You get these questions in the school exam. What value you are getting? Tell me, it's easy. What value you are getting? Sai? Neha? Divya? Sydney? Hariharan? Vaishnavi? Prakash? Nanya? Netra? Sheetla?
Sir.
It's very easy. Just put the values. See. So minus 12a square root 2 times a plus 2 root 2 times a whole cube divided by 4a square minus root 2 times a whole square whole to the power 3 by 2. So if you solve this minus 12a square, or I can write it as minus 12 root 2, 12 root 2 a cube plus, it will be root 2 times root 2 times root 2. So that is 2 root 2, right? So 2 root 2 into 2, that is 4 root 2 a cube upon, so 4a square and root 2 square is 2, 2a square. So 4a square minus 2a square, it becomes 2a square to the power 3 by 2. So it becomes minus 8 root 2 a cube upon 2a square to the power 3 by 2. So you can see it from there that you get a negative value. Agree or not? Without solving much, I can say that, like, if I solve that more, if you want to solve more, minus 8 root 2 a cube upon, it will be 2 to the power 3 by 2 is 2 root 2 and a to the power cube. Yeah, that is there. So you'll get minus 4 to be exact. That is negative. That means this value is giving me what? Maxima. So L is equals to root 2 times a is maxima. And what was my breadth? What is my breadth? Breadth was under root of 4a square minus L square. Find the breadth from there. Under root of 4a square minus L square. So under root of 4a square minus root 2a ka whole square. So it will be under root of 4a square minus 2a square. So it will be root 2 times a. That means L is equals to b. This is a square. Square having maximum area. Agree or not? Tell me.
Yes, sir.
Yes, sir.
Got it? This was quite lengthy, I agree. But the thing is that they may ask this question in 4 marks or 6 marks in the school exam. Understood? Nothing much you have to do. You just have to put just one single effort in solving, preparing the equation and then differentiation. Two things only. Okay. Written, everyone. Shall we move on to the next question?
Okay, sir.
Right. Okay. Try to solve this one. Show that the right circular cylinder of a given surface area and maximum volume is such that its height is equal to the diameter of the base. So what the question is saying is that we have a like right circular cylinder that looks something like this, and the radius is r, the height is h. The radius is r, the height is h. Okay. Now, for a specific surface area, so what is the surface area? So 2 pi r square, 2 pi r square, okay, plus 2 pi rh. Agree with this or not? Right? 2 pi r square plus 2 pi rh.
Sir.
You didn't ask me one question. There are two circles. So why did you take only one 2 pi r square? Sorry, there are two circles, and then we have one curved surface area, isn't it? You understand the surface area of cylinder? Are you fine with it? Yes or no? Everyone?
Sir.
Okay. So for a specific surface area, we need to find that the volume is maximum if the height is equal to the radius. Sorry, diameter. That is it. Okay, height should be equal to the diameter. So what we have to do from here, we'll calculate the height. That is our condition. That is our variable. That is maximum. Okay, so height will be what? So it will be s minus 2 pi r square upon 2 pi r. That will be equal to the height. Okay. Now what is our volume? Volume for this is pi r square times h. This is the volume. So instead of height, you can substitute it s minus 2 pi r square by 2 pi r. Right? So from there r gets cancelled. So we will be pi r times s minus 2 pi r square. Understood? So we can be written as pi r s minus 2 pi square r cube. Now I need to get my volume to be maximum with respect to the radius or the height. So I have the radius, I'll differentiate with it. So you'll be getting after differentiation for volume from here, 1r term is there. 1r term is there. One r term is there, so you'll get pi s minus from here r cube is there. So r cube comes here, it will be 3 into 2, 6 pi square r square. Agree with this, yes or no?
Yes, sir.
So from there you'll get, if you equate this with 0, you'll get r as what? So r square will be, if you cancel pi from here, so you'll get s by 6 pi, that is our r square. Understood? This is our r square. Now we'll double differentiate it. We'll double differentiate it. This equation will double differentiate to check whether the thing that we are getting is maxima or minima, dr square. So it will be what? It will be pi s, that will be 0, and it is minus 6 pi r square, so it will become minus 12 pi r, and r square value is s under 6 pi. So it will be minus 12 pi into root over s by 6 pi. Agree? So this S surface area can never be negative. 6 pi not negative, 12 pi constant, and already a negative sign is there. That means this is less than 0. Negative. So R at under root 6 by, sorry, S by 6 pi is what? Maxima. So now put H. S minus 2 pi R square upon 2 pi R. And put R is equals to S by under root over S by 6 pi. Put it. Tell me the value of H. Tell me the value of H. Or directly what you do now, instead of doing this much, you know that R square is equals to 6 S by 6 pi. You substitute S. S is equals to 6 pi R square. You directly substitute, you'll get the same thing. So from there, if I substitute X is 6 pi R square minus 2 pi R square upon 2 pi R. So it will be 4 pi R square upon 2 pi R. So this is 2 and this gets cancelled. So H will be equals to 2R. That means H is equals to diameter. So we got that when H, the height is equals to the diameter of the cylinder, we get the volume to be maximum for a given surface area. Agree or not?
Yes, sir.
Okay, so write it down. Everyone understood it or not? Sydney, Divya, Neha, Sai, Vaishnavi, everyone.
Yes,
I
sir.
want the answer from everyone. Yes or no?
Sir.
Sir.
Good. Written? Written?
Writing, sir.
Yeah. Tell me if you need to change the slide. Done? Tell me if it is done. I have to start another class at 6:15.
Done, sir.
Okay. This slide also?
Please, sir.
Done?
Completed, sir.
Yes, sir.
Okay. So you like the session? Try to solve more questions. Okay. Get the doubt cleared, and that's how you should move forward in maths and physics like chapter subjects. Okay. Any doubt? Shall we end the session?
Okay, sir.
Okay, sir.
No, sir.
Good, good. Okay then. Bye.
Thank you,
Thank
sir.
you, everyone.
Thank you, sir.
Sir.